Right, so in starting my turntable, one of the things I've got is a stepper motor, which I'm going to be attaching my turntable to, and somehow I'm going to have to make a plate up to attach this to the railway base, and then obviously the cables and that for the Arduino. And I've been working on cutting out a couple of circles out a bit of MDF. This is just going to be my outer ring for the turntable where the tracks have come up to, and I cut out the inner circle, which I was going to use probably to cut two strips down, lines down here now, to put the track on to make this bit the turning bit. That's the theory. See how that goes. Most of this was cut out using a router and a template thing that I'm going to have. So for now, I'm going to try and cut out the two straight bits, get a bit of track to measure it up to make sure it fits, and then see if I can attach this to the stepper motor and see if the stepper motor is powerful enough to move this, being quite a thick MDF. Alright, so as you can see, my track's going to be going across the middle, the centre part, and I'm going to be doing quite a close, about a couple of mil from here, cut down this side. But on this side, I'm going to leave a bit of a walkway, so I'm going to cut it a bit bigger so that it would simulate the people will be able to get out of the track, the train, and be able to walk down this side of the running track. Right, so I've made up the wooden plate for putting the stepper motor onto it, so I can fix it into place. And I've already got a hole cut into my baseboard, which will take the stepper motor. If I just push these cables down, and then that sits in there quite nicely. So my next thing in there is to draw around this, and I'm going to router around this so that this drops down and recesses into the main baseboard, and then hopefully get that as tight as possible so that there's no movement at all in that, and then that can be screwed into. What I've done is I've drilled a hole through the side here. There's a nut in the middle which this connects to, so that as it tightens up, it pushes against the shaft and keeps it tight on the shaft. And at the moment it seems to be quite okay, not perfect. I still might modify this. Maybe I might make it narrower and lighter. It's catching on the back ends, which I could probably sand down. That's not a major problem. But the biggest thing is whether it sits there straight enough or flat enough to be able to get the tracks that come up to connect onto it. So that's probably my biggest issue, more than the computer side and the electronics side of it. The motor's now screwed into place into that recess that I made, so that's quite nicely tightened in there. But it's just this, that's my biggest worry. Down here I've got the motor driver shield, which is a if I get it right, is a L298N. This runs on 5 volts logic. Well, it's basically these wires here that go over to my Mega, and I've connected them into here, and I'm running on pins 22, 23, 24 and 25. So that's the control side of it, and then the motor connects to these outer ones. So there's 2 pairs there going to one coil of the motor, and the other 2 pair there. And then the motor's got the 4 cables coming out of it. If you haven't used stepper motors before, and if you continuity check across 2 of the pairs, so say I take these 2 and continuity check, I'll have a very low resistance across these 2, and a high resistance between any one of these to the other side, so, and low resistance across these 2. So you can then work out what to the motor pair, and you can put them in either side of your shield. And because I'm running also a stepper motor of 12 volts, I tried the 5 volt ones, but you can hold that with your hands. It's not powerful enough, not enough torque on it. And so I'm running a power supply here, which is connected to my bench power supply at the moment, which is up here. But it will be coming off my main computer power supply down below. But I'm running 12 volts on this red cable coming in, and ground, and this ground connects to the ground to the power supply, but also connects to the ground for everything else. All the grounds are connected together. I've said this before in videos. If you don't connect this ground up to your Arduino ground, even though it's running on a 12 volt, the grounds, if you don't connect them up, the whole system won't work. So that's one of the things you need to take into account. Right, so the turntable's now in place, as you can see here, and it's powered up. So I'm going to go for a demonstration of it working. I'll leave the turntable set up here, this part of the screen, and I'll show you it working with this turntable part here, and then I'll go through the full code and setup. So I'm using sensors on these, but I'll explain all this in a minute. So I have to click on a sensor to move this turntable into a certain position. So if I go to this one, which is the full revolution I'm going to go to, you can see the turntable turned, coming back, and then the next position, and finally back to the beginning. I'll go around again, show you it coming backwards and forwards. And so this is the furthest point. If I click this to go back, you'll see where the screwdriver is, it actually comes back dead on to the same place. And so this is all working purely on the stepper motor and stepper positions. It's not got no sensors or relays or anything, reed switches or magnetic switches or anything like that involved, because I found that when I was using them it wouldn't be accurate enough to get to it. But then this is still early days, I'm not sure how accurate this is going to be, but it seems to be working okay at the moment. And I've got 4 positions set up. Right, so I'll go through part of the code. So the first thing you need to do if you're setting this up is you need to know your stepper motor, the type of stepper motor you've got, and how many degrees of movement per step. I don't know whether I can find mine. So the stepper motor that I've got at the moment is this NEMA 17 stepper motor. You can get the serial number off the stepper motor, which is this one up here, the 17HS13, and all the numbers there as well. Which brings me to the Google search that. It gives me the data sheet for this stepper motor. So it's supposed to be a 12 volt stepper motor DC, which is what I'm running it on, which gives me enough power to move it. But I might be looking at a different stepper motor in the future. For some reason this stepper motor gets hot, and the also the H-bridge device for the controlling of it is getting hot as well. So I don't know whether there's a problem with that. But this is what I'm mainly looking at, is this stepper angle 1.8 degrees. So every step is 1.8 degrees, so you get 360, you divide that by 1.8, and that'll give you the settings that we're going to put in the Arduino code in a moment, which for mine is 200. So we'll now have a look at the Arduino code for that. So most of the top part of the Arduino code is the same as what we've done for everything else for setting up the turnouts. The only difference here is we've now included the stepper.h library, and down here we have a setup for the library, which the first figure of 200 will be the amount of steps your stepper motor takes to do a full revolution, and as I explained just now, that for me that's 200. And then the next one is the pins that you're going to use from your Arduino, so I'm using these pins, which connects from your stepper motor to your H-bridge device, whatever you're using. So that's that setup, and so that's most of the setup for the stepper motor. Apart from this last one down here is the speed that the stepper motor runs at, which I've set to 10 on mine, which works out quite nice. I've done it too fast because the trains just fall off. Plus, if it's too fast, it goes out of sync a little bit, because when it stops, it's quite a sudden stop, like putting your foot straight on your brakes in the car, so everything moves. So I'll keep that as minimum as I can, but it does mean it judders a little bit, which you saw earlier. So going through my variables, I'm doing 4 positions at the moment, just for my testing, and they're different varying positions. So I'm putting all these into an array called positioning, which I've given 4. That sets up four integers, 4 variables, where I'm going to store the bits coming in from JMRI. So this is just purely a place where I'm going to store the bits coming in from JMRI for the 4 positions. I have a current location which changes every time. Every time it goes to a location, it gives a figure into here to say how many steps we've gone from 0, which will be my reference. 0 is going to be my starting point, reference, and if I went to the full 200, that will be the maximum I can go to, and then it'll have to go back in the opposite direction to get back again. So current location is equal to 0. Like I say, that changes. Steps is a variable where I put in the amount of steps we're going to do every time we click on something. As you'll see in a minute, it's a little bit of calculation on that. And then we've got the locations. So 4 locations, 4 variable integers, giving me the positions of steps that I'm going to go to. So position 1 will be 0 steps that we're going to go to, 0 position. Then we've got 10 to get to the next one, 30 and 100. So you'll see how they're going to be working in a minute. Void setup, we have a serial.begin to get the communication which we need for the CMRI as well. So, and I did use it for some of the coding, but I've commented a lot of that out, so you see that in the code, but it's been commented out to try and keep the code more slick and faster. And then the void loop, I've got the CMRI.process, and we read the inputs coming in from JMRI over the CMRI communication, and we're storing them into each of the positions, which I said earlier, which were the arrays. This is quite basic stuff. If you've seen my turnout stuff that's been working, we're using these as the bit addresses, and there will be a bit address back from what you put into JMRI. And in JMRI, these are going to be using the lights table. So these are literally lights that you're switching on and off, and they're sending out a 1 bit each time, or 0 bit when they're off. And then we have, I'll show you all of it. These are 4 if statements, and each if statement is almost identical apart from certain mathematical functions inside them. So the first if statement says that if positioning 1 is equal to 1, which means we'd have switched on the light for 1 on JMRI to get it to that position. If it's equal to 1 and the current location is not equal to 0, we're saying, because this would be position 0, we don't want to keep going through this if we are at location 0. So we sort of need to get rid of that so it doesn't keep going through it. Although you can switch the lights on and off, which I'll show you in a minute, but if you left it switched on, it's not going to keep going through this if statement because you left it switched on, because it'd be at, if I'm asking for current location of 0, we will actually get to it and make current location 0. So it'll only go through this if statement once. Like I said earlier, these serial statements you can ignore. So if I delete these out, so you can see that it's not too big a code. It just makes it a little bit easier to read. So that's what this if statement is doing. So if we switch the light on and we're not at location 0, then we'll make up a math statement. So how many steps we're going to move. So we have the location 1, which we set up here, was equal to 0. Yes, we get location 1, and then we're going to take away the current location. So we're obviously not at 0. We might be at, say, 10 location down here. So we get 0, we'll take away 10, we'll end up with minus 10 because we need to go the opposite direction, anti-clockwise back to get to this location. So that steps will become minus 10. We then send to our stepper motor minus 10, and the stepper motor will move to location 0, and then we set current location 0, so we only go through this statement once. Now, a good example of this, if I go down to position number 4, taking out these bits again. So if we were at the moment at location 0 and we want to get to position number 4, we'll click on the JMRI to make the light turn on to position number 4, and we'll say that we're not at current location of 100 because we're not there at the moment, so we can go through this if statement. We then go and say that location 4, which was set at the beginning, which was equal to 100, if you remember up here, location 0 is set at 100 minus the current location, which at the moment, say we're at 0, will equal 100. So the steps will equal to 100, and it will pass 100 steps to your stepper motor, and then it'll move to that 100 location, and then it'll set current location to 100. Meaning that when you go back to here and you click on this one, location 1 will be 0, current location will now be at 100. If you clicked on this, 0 minus the 100 will give you minus 100, so it'll send minus 100 steps to bring you back to location 0. So hopefully that makes sense. I might show you this side by side with the JMRI when you show you JMRI so that it all knits together. So looking at the JMRI now, the first thing is first, I've set up a turntable here, which I think if you go options, you can never remember where to look for these, add turntable, which will add your turntable onto your screen, and then right click on your turntable. Moved it, hopefully I can get that back. No, doesn't allow me to drag it back that easy. There's no control Z on that, I think. Anyway, that can stay there. If you right click on it and then click edit, you want to make sure you haven't got this DCC control turnout clicked, this bit here. make sure that's unclicked, because we're not running through a DCC controller like you would do conventionally with any of the off-the-shelf stuff that you buy. So make sure that's clicked, and then all we're then doing is making up some sensors, and we're putting these dots are just sensors. So we'll go through that first, making up the sensors, showing you them. So you need to bring up your tables, and as soon as I bring that in, mine seems to lose. I seem to lose this bit, so I can't pull it out. There it goes, comes out again. Bit of a weird thing. Anyway, bring up your tables, click on sensors, and then you're going to add some sensors which are internal sensors. So if you click add on these, leave it as internal, give it a hardware address, which for me, I think I put IST1, IST2, IST3 and IST4, and then give it a username, which I'll put down as turntable _ S1 for sensor 1, because these are sensors, turntable S sensor 2, turntable _ S3 and S4. So set up 4 basic sensors here, so you got them, and then go back to here, click on your sensors to add them, and that again is not showing. So you click on your sensor icon here, select from your sensors that you just set up, and then drop them onto your screen and position them roughly where you want your turnout to be going. So I'll just drag this one out, so you just dropped it on the screen, and you can position it anywhere. I'll put them inside the turntable like that. You can have them to the side, you can have them wherever you like. So going back to your tables then, you now click on your lights table, which mine's taking ages to change over, and we've got to add the 4 lights. Now for adding these 4 lights, we give it the, if I bring one up, you are doing the CMRI now and the drop down, not internal, and for the address, you give me the address of the 4 bit numbers that I gave on the Arduino. Now this is the same as what we did before in the turnout, so this is address 7, 8, 9, 10. So 7, 8, 9, 10. I'll just minimize this, keep this on the screen. So we've got 7, 8, 9 and 10 here. So for my address, I've got 1008, which is the number 7, 1009, which is number 8, 10010, 10011, which would be 9 and 10. So you can see that they're all on the Arduino, they're one behind the JMRI for the addresses. Number 1 means we are node number 1, and then the last figure is the bit number address that we're sending through to here. So hopefully that makes sense. So we set up the address, and then we give it a name, any name you like. I'll call them T1 to T4. So that sets up your lights. Then click on the edit button for each of these, then click on add control. I'll just do the drop down to by sensor, then drop down on the sensor number or control sensor, and pick out, for this one being number 1, turntable S1. I'm not going to do this, get rid of that, because I've already done it. And then you click update for it all, so they all update. So I'll go through each of them to show you. As this one, this light will turn on when turntable S1 is active, and this one will turn on when turntable sensor 3 is active, and so on. Now it would be nice if I could add other controls in here that turn it off, which I might be able to do. I've got to look at this, so that it turns on when S3 is active and turns off when any of the others are active. So you should now have 4 lights set up with 4 addresses connected to your Arduino addresses, which are all controlled by your sensors on here, and then that is all controlled by these sensors on here. So all going well, and we'll bring up the camera with the current camera set up, and it's all powered up at the moment. If I click on, this is position number 1, so this is the position it's in at the moment, which would be 0 on the Arduino code. So if I click on this one, position number 4, which would be 100 on the Arduino code, so I need to go 100 steps in the clockwise direction. We click on it and see what happens. So only other way, then I'll go for all of them this way, and then I go for this way to show you when switching them on and off at each time. So position number 1, this will be position number 1, I think. No, position number 2, because that's 1, sorry. Position number 1, 2, yeah, I'll get it right in a minute. would be 10 steps going in the, what I thought was clockwise direction, would be anti-clockwise as you look at it on the screen. And then position number 3 would be 20 from 0, and this one would be the 100. And then going back, if I go back to here, which would be the 20 from 0, and this would be 10 from 0, and then back to 0. So if I was at 100, but didn't want to go back to 0, but I want to go back to here, which would be the, I think it's 20 from 0, it will go to that position. And then to 10, and to 0. Or so it works really well at the moment. At the moment I've not got too many problems with it. I don't think it seems to line up every time with this screwdriver. That's why that screwdriver's there. And the code all works. I'll try and get this on my website as soon as possible and showing it working. But I've still got a lot to do. I've still got an outer ring to put on and all the tracks and everything else. And I've still got to practice this enough to make sure it works. And I need to look at why the motor's getting hot, a little bit warm. It's only warm, but whether that's normal because I'm running it at a slow stepper motor. Check my voltages, make sure I don't over 12 volts. That might be another reason. And then I've got to. I also want to see about these sensors, whether I can click on one of the sensors so that turns on. I mean, if I now go and click on sensor 1 or 0, that turns off, which I think probably would be allowed to do. So it does it automatically. But that's it for this first part of my demonstration on how to build your own DIY turntable at a very low price. I hope you enjoyed watching it. Please click on subscribe, and I'll try and get my next video up and running as soon as I work out the code, because I've had a few problems with this one, so it took me a bit of time. But yeah, thanks for watching. Hope you enjoyed it, and good luck with your turntables and your railway.